Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, we have started doing the videos. I have started doing the videos on phase 2 stability, and we were talking about intact stability criteria satisfaction as required by ISC code 2008. So there we had talked about general criteria to be satisfied. Now the additional criteria which are to be satisfied by passenger ship is when a passenger ship takes a sharp turn, the heel that is caused because of taking the sharp turn should not increase more than 10 degrees. Or if there is a crowding of passengers on one side, then the heel once again should not be more than 10 degrees. So these are the two criteria. Let us see how we can mathematically show that, demonstrate that our ship, the passenger ship, will satisfy the criteria. So here is the data of one of the ships, a passenger ship. It has kg 7.6 meters, km 8.9 meters, speed 18 knots, draft 9 meters, kb 4.8 meters. The number of passengers on board 2,400. The breadth of the ship is 27 meters and technical diameter when she takes a sharp turn is 610 meters. So let us first see whether she will satisfy the criteria in respect of maximum heel that is caused while she takes a turn. Now basically, first let us understand what actually happens. Here's a draft and the ship is suppose going to take a turn on the starboard side. Suppose this is the center of gravity of the vessel and this is the center of buoyancy of the water, right, underwater. Now when she takes a sharp turn, it is like centrifugal force acts radially outwards this way, and the ship is not thrown in this direction naturally because there is opposition from the water, and the opposition that is or resistance that is caused by water can be assumed at the level of center of buoyancy. So can we say that this is the lever that causes the ship to heel, and this lever is nothing but, we can say, kg minus kb. It is also sometimes taken as kg minus draft by 2, which is kind of slightly approximate, but kg minus kb would be more accurate. Now what happens? Now the centrifugal force we know from the physics is mv square upon r, right? So mv square upon r can be considered as delta minus g, because mass is the weight divided by acceleration due to gravity, or we can say weight is equal to mass into gravity. So in place of m I can write delta by g, and v square, v is in meter per second, divided by r. This is the centrifugal force, and multiplied by this distance gb is the upsetting moment. This is the upsetting moment which is going to cause the heel, and that riding moment is delta gm sine theta. Delta can be considered as the weight. When we talk about the forces, we have to take weight into account rather than the mass. So delta gm sine theta is the riding moment. Riding moment is equal to upsetting moment at equilibrium. So what happens is delta gets cancelled, and what we get is a resultant we get is sine theta is equal to v square upon gr gm multiplied by gb. So sine theta is equal to v square upon gr gm multiplied by gb. We want the actual vertical distance between g and b. So actual vertical distance between g and b is not gb. We should be writing gb cos theta, because this side upon gb is equal to cos theta. So this vertical distance is gb cos theta. So instead of gb we should be writing gb cos theta. But when cos theta goes on the other side, it goes on the denominator and it becomes tan theta. So the final formula is tan theta is equal to V square upon GR GM into GB. Right? So this is how the formula is derived, and let us see if we can find out whether the criteria in respect of healing is satisfied. V has to be in meters per second. Now what we are given is in nautical miles 18 knots. What we have to do is 18 multiplied by 1852.3 equal to divided by 3600. That gives meters per second. That is 9.26 meters per second. So V is equal to 9.26 meters per second. So we have got V. Now acceleration due to gravity is 9.81. R should be 305 because tactical diameter is 310. And GM, what is GM? The km is 8.9 meters. Km is equal to 8.9. kg is equal to 7.6. So GM. Free surface correction is not given, otherwise we would have taken GM fluid. Assuming that free surface correction is 0, so I minus 0, so GM fluid is equal to 1.3 meters. So I've got GM now. GB. Now GB is the difference between kg and kb. Now kg is 7.6 and kb is equal to 4.8. So GB is equal to 2.8 meters. So let me put the values like tan theta is equal to 9.26 square divided by 9.81 into radius 305 into GM 1.3, and this is multiplied by GB, that is 2.8. So this is how we find out if theta is more than 10 degrees, the ship does not satisfy the relevant criteria. If theta is less than 10 degrees, the ship satisfied, the passenger ship satisfies the criteria. Let us see if the ship satisfies the other criteria. Other criteria means like you can see the ship is 27 meters in breadth. Let us say initially the passengers are distributed all over and they are relaxing, they are in sitting posture, and then let us assume that the passengers, instead of being all over, they are concentrated in say 1/3 of the breadth on any one side, which means that originally where the center of gravity of the passenger was halfway, that is in a center line, you can say this is 9 meter, 9 meter, 9 meter, because this thing is 27 meters, breadth is 27 meters. Now this point where the passengers get concentrated 1/3 is 4.5 meters from one side. Now over here the distance from the other side is 13.5 because originally the center of gravity was here. So how much is the shift? This is 13.5, this is 4.5, that is total 18. This plus this is 18. So remaining distance is 9 meters. So we say that transversely the passengers on the ship, they have shifted by 9 meters. Let us see what happens because of that. The weight of each passenger is to be taken as 75 multiplied by a number of passengers, 2,400. So that gives me 75 into 2,400. That gives me 180 tons. There's another thing that happens, like initially the km is 8.9, kg is 7.6, so gm is 1.3 meters. Now, originally when the passengers are relaxing and then when the passengers stand up, it is assumed that initial center of gravity from the deck is 0.3 meters and later the center of gravity is about 1 meters. So this is 0.7 meters is the difference, like compared to the center of gravity of a person while he's sitting and while he's standing. So should we assume now that these 110, that is the weight of the passenger, moves upwards by a distance of 0.7 meters, right? So let's say the displacement of the ship is 19,000 tons. So what happens when a weight of 180 moves upwards by 0.7 meters? W into D divided by the displacement, that is 19,000 tons. 180 into 0.7 equals divided by 19 gives me 0.007. So I should say that the GM reduces by 0.007, so I'll minus it here, 0.007. So the new GM is 1.293 meters. Let us now see the effect of the shift of the weight transversely. So what is happening is there is a weight 180 tons. It is shifting transversely through 9 meters. The displacement of the ship is 19,000 tons. So the ship's center of gravity would move transversely by 180 into 9 equal to divide by 19000 gives me 0.085. Now the list that would be caused because of this is tan theta is equal to gg1 upon gm, that is 0.085 divided by gm, that is 1.293. So once again we'll get theta from here, that is gg1 upon gm 0.085 divided by 1.293, and this way if theta I get more than 10 degrees, that means the ship does not satisfy the criteria, and if the list is less than 10 degrees, the ship satisfies the criteria.